Hello everyone, I am Raki and welcome to this Unreal Engine 5 tutorial. In this tutorial, we are going to design a scalable interactive object system in Unreal Engine 5 using blueprint interfaces. But this is not just about opening a door or picking up an item. We will be designing a clean, decoupled, production-ready interaction architecture, the kind of system you would be using in your real projects. By the end of this session, you will be understand how to build an interaction system that are scalable, modular and easy to extend without relying on casting or hard references. Let's first understand the common mistake developers make. Let me show you one of my projects. This is a simple game in which you will be collecting some objects and avoiding some obstacles. Let me show you the characters, references and how it's working. So you will look into it, you will find this is a simple player object which has some obstacles and coins to be collected by your ball. If you right click and choose reference viewer, you can easily see how these objects are using my BP rolling ball. This is because we are using the hard references every time we are using either we want to check if the ball is interacting with the coin, with an arrow, with an obstacle or any of other object. So every time your objects are casting to the ball or ball is getting casted by these. Here you can see every time your object overlaps, it checks if the object is overlapped by a coin or something else. If I'll open the coin or checkpoint, you can see every time your checkpoint is checking if it is interacted with the rolling ball. So we are using so many hard references. Let me show you another example. Here also we are using casting node multiple times. Every time we need to check, we have to cast the nodes. So this is the problem with hard references, and every time you have to cross check whether it is a pickable object, collectible object, interactable object or any object you want to identify. Every time you need to cast it. In a small project, casting works fine, but as your project grows, this approach creates tight coupling. Every time you are modifying your player blueprint, you are using multiple cast nodes, by the time it becomes very hard to maintain all these things. And as your project will grow, it becomes more complex. It will be very difficult to add new elements, and every time you have to repeat the same things, but with different class names. That's why instead of using casting every time, we have to create a system in which we can easily create interactable objects or a pick collection system or a weapon system or any type of system which you want in your project, so that it will be easily scalable and it would be easy to add any number of elements to it, and you don't need to code every time. So instead of using casting every time, we will be using a solution to these things called blueprint interfaces. So let's first understand what are blueprint interfaces. Blueprint interface defines a contract. It does not contain a logic. That means we will be simply telling the system that we want this to perform, and how it will be performed will depend on the implementation of your function. For example, if I'll have a object, let's say if I'll take this, or this is an example, so my ball will be asking to interact with either a coin or a block or a arrow. It will be directly asking to interact directly, and it depends on your object how it will perform when your player will interact with it. So any actor that implements this interface agrees to respond to the interaction function. We no longer care what object is, we only care whether it implements the interaction capability. Let's check it with an example. So how we can do this in a real project? So I have this third person template in which we have a BP third person character. We have an input system already mapped to my character, and I have a default map. This is called third person map. So we will be using the same to create our interaction system. So let's first create a interface. So how you can do it? Let's just create an interface by just right click in your editor, choose blueprint and go to the blueprint interface. Once you select, just name it BPI resembling blueprint interface underscore interactable. Once you are done, you have to double click the BPI interface and it will open up a new editor. Here you will define your own functions. For example, let's create a function called interact. So whoever interactable object will implement this interface needs to implement this function. So every time a different object, it will have its own behavior. You can also have some inputs and outputs related to this function. Maybe sometimes you will want to give some output, then you will be adding them here. For example, found or something, anything you want to return. It may be any type. But for now, I don't require anything, so I'm leaving these inputs and outputs empty. Compile once and save. Now let's go to our content browser and let's create an object through which I want my player to be interact. So let's create a blueprint of type actor. BP underscore, let's say door. Door. Double click to open it. Here we will be arranging how my object will be looking. So let's add a static mesh. SM underscore door. Let's add up one more static mesh having SM underscore main door static mesh. Let's push it here. So we are all set visually, but we have to next add a collision through which my player will be interacting. Or you can also use overlapping actors or line trees through player to get to know with which object my player is colliding. We are all set with the visual appearance. Now let's go to the class settings. Here you find a section called interfaces. So now we want our door to be interactable. So we will be implementing our BPI interactable interface inside this blueprint. For this, you have to go to implemented interfaces, add your interface which is PPI interactable. Once you select, it will be available here. You can see it here, and whatever functions you have defined in the BPI interactable will be available under this interfaces section. Once you double click on event interact, it will create a new event to be fired by this door. For now, let's just create a print statement by this door. Open door. Compile and save. Now go to the player. Let's place this door inside our world. For now, when I interact, nothing happens. Let's go to the static mesh and first add a simple box collision so that my player will not go through the door. Let's check it first. Yes, it's working. Now what we want is that whenever my player come in front, it should open the door. So for this purpose, let's go to the player, and here we want to interact your player once it reaches to this section, and we also want some inputs by my player so that to agree your player that he wants to interact with that object. So for this purpose, let's move to the enhance input system and create a action. Go to the inputs and create a new input action. Let's say interact. Double click to open it. We will set it to the boolean, and let's add a trigger pressed. Save. Go to the IMC to add my new input action in this mapping. Add your action IA interact, and let's add a keyboard event to it. Press E by enabling this keyboard. Once you are all set, let's check if it is working. We'll make sure if my character is using the same IMC. Yes. Now let's go to the adding IA interact. Let's check first whether it is getting fired or not. Always make sure what you are doing is working. So every time I'm pressing E, it is getting fired. So we are good to go. Next, what we want is whenever my player interacts with this door and press E, then only it should get interacted. For this purpose, we will check whether your player is interacting or overlapping some interactable objects. For this purpose, you have two options. Either you can use overlapping actors by directly using the get overlapping actors, or you can also do a line trace by using line trace by channel. Either way, you will be getting with which element you are getting hit. This will give you only one response at a time, and overlapping actors will provide you an array of actors. So if you want to check multiple objects at the same time, go with the get overlapping actors, and if you want to check one at a time, use line trace by channel. For now, I am using get overlapping actors. You can also make a filter here. Right now, I am not taking any filter because we will filter according to the interface implementation. So let's check first if we will check if there are some elements inside this overlapping actors. Then we want to perform some things. So for this we will be using for each loop, and we will pass this element here. So every time we are overlapping the actors, we will collect them, or we will interact them with simultaneously. Here we will check whether these elements implements the interface. The node is called does object implement interface. If the overlapping actor will have my interface implemented, which is BPI interactable, and if this will return you true, what I'll be doing is, if the condition satisfied, I'll directly call my function called interact. Let's check this if it is working or not. Let's take a recap. When I press E, this event will get fired and it will check if it is overlapping any element which implements the interface BPI interactable. If this is so, it will call the interact of that object. In this case, with door. Press E and the interaction is fired. If I'll press E outside the range of my door, nothing happens. So once I move, it will fire my event. E, the open the door. That's it. Now whatever we want, we can implement it the same here. You can create either a custom event of how your door should open or how your object should behave when your event interact will fire. In the same way, you can also create your other objects. For example, let's create an object called pp coin. pp underscore coin. The same implementation will be done with this pp coin. We'll add the bpi interface. On interact, we will call coin collected. Let's add a cylinder. You may also use your own custom static meshes if you have. I'm just creating it to look like a coin. Let's add a material. Like orange. Or something like yellow. But I don't think I have a yellow one. But this will fine for now. Let's add a collider also. Let's add a sphere collision. Make sure your collision is bigger than your static mesh so that your player can easily interact with it. We don't have to do anything else as we have created the interfaces. So when I go to door, it will call open door, and when you come in contact with the coin and press E, it will call coin collected. Now you can implement anything like how your door should be open here. For example, let's make your door get open by a timeline. Let's use a timeline. Add a timeline node door open. Create a flow track. Rotational value of your door. Let's make it 2 seconds long or either 1 second long. Add a float key by right clicking add key with 0 0 and another key to get the final value. So door will be linearly open. This will show the flow how your smooth curve will move. You can also make it smooth by adding more keys to it and make your object move accordingly. But this is optional. So let's get back and get your object, your mesh. This you want to rotate. So we will get this object And let's set relative rotation of the door. Break the result, and whenever your timeline is getting updated, we will rotate our door. But in which direction? So let's press E and move it like this. You can see the value changing is the Z value. So we want our door to be open in the Z rotation along the Z axis. So we will be modifying the Z axis only and not the X and Y. Let's use this value and add a multiplier so that I can set the rotation to any range. Let's check. When I press E, the door gets open. You can do the vice versa whenever your object is leaving. In the same way, let's go to the coin. Now, when your coin will interact with the main player, let's inform our player that he has collected a coin, destroy it and increase your player's score. So first, what we will be doing is create a function, and before that let's add a variable coin collected to get a count how many coins your player has collected. Make it integer, the default value is 0. Let's make a function collect coin. Let's add an input value coin value of type integer. So whatever amount we will receive from this collect coin will be added to my current coin count. So let's get this value and add my current value to this coin value and we'll set the coin count. Let's display the final coin count. Or directly you can use this value also as it is the updated one. Hit play. Now when you press E, it will get open, and when you go in front of your coin and press E, what happened? Oh sorry, we forgot to call this collect coin when your coin is interacting. So now what we have to do is we have to interact with my player get your player cast to third person sorry not controller my player get player character cast to third person character, and let's call the function called collect coin. Each coin can have its own value, so let's create the coin value inside this coin. of type integer. Let's have the value 10. So we'll pass this coin value in this collect coin function. After passing the value, we want to destroy our object. So let's call the node destroy actor. Let's test it. We'll get the 10 coin count. Let's add some more coins. You can make it call automatically if you don't want to interact your object. So once you play, you go near to the coin, and every time you collect a new coin, it will get added to your player's score. This is how you can make any number of interactable objects in your game. Whether it is a treasure box, whether it is a weapon, or let's say switches, levers, lift, anything. Whenever you have to create your new interactable objects, you have to just create your object and add your interface. In real production projects, we can extend this architecture further. In multiplayers, you can have your server RPCs. In larger systems, you can have a system to handle a wide number of actors easily through the system, or we can integrate gameplay tags or validation logics for a complex gameplay. Interfaces defines communication, not replication. That's why they are very important to be used inside a system. Let's recap what we have built. We started with a third-person template. We created an interface by right-clicking blueprint interface and added a function called interact with no parameters in inputs and outputs. We created new objects of type class actor by right-clicking blueprint class actor, which we want to be interacted by your player. We added some visual appearances and a collider. In the event graph, we called interact event. But before that, make sure you have added your interface inside class settings. Go to implement interface and make sure you have added your interface. Once you added, all the functions which is inside this BPI interactable will be available here. Once you double click, it will automatically add it. If it has no parameters inside input value, or if has input values, it will be appearing like this. But if you have any output value, for example, let's add another function called test out function, and let's add a parameter called return value. Hit compile, save. You can see the new function will be automatically available here. Once you double click, if it will have a output value, it will be looking like a function like this. Now here you can add your own functionalities and then return the value. So whenever it will get called, it will get some return value. So every time you implement your interface, you don't need to add those functions in all the objects. They will automatically get added. For example, If you want to display something like um, the name of your object, or if you want to display some message over on top of your objects, you can simply create a function inside your interface, get the output value as a message and pass the message from here. For example, let's change this function name as interactable name, get interactable name, and let's change the value to string. Here we will be passing door and inside coin let's pass the value coin. When your player calls this interaction, let's call get interactable get interactable name. Let's print this. Once you hit play and when you interact with the object, it will display the name of the object you are interacting with. So this is how this function works. I hope you understood it very well, and now you will be able to create your own system of either a collectible system, a weapon system, inventory system. Anywhere you can use this concept. This will make your systems easily scalable. Through this architecture, you will be avoiding the casting and tight coupling of the nodes. Also, you will be making unlimited number of interactive actors. Let's quick. So what we did today is we designed a interface driven interaction system that eliminates casting, reduce coupling and support unlimited interactive objects without modifying the player blueprint. We built a blueprint interface called BPI Interactable. We created multiple objects using the same interface and with their own behavior. We made our character to interact with all those elements by cross-checking if they implement the interactable interface and directly calling the same function every time we are interacting with any type of interactable object. We will always be calling the same function called interact. This is a clean system and it's very dynamic. Most importantly, we built a scalable architecture, not just a feature. This approach keeps your project modular, maintainable, and production ready as they grow in complexity. Thank you for joining this session, and I'll see you in the next Advanced Unreal Engine tutorial. Hope you have learned something. Thank you.